You know, in science, we usually hear about the big breakthroughs, right? The eureka moments. But today, we're talking about the exact opposite. This is the story of a scientific breakup, a theory so completely and totally wrong that its own creator decided to give it a public burial. Let's dig in.
I mean, just imagine dedicating years of your life to one big idea, only to write this. This is the opening line from the lead researcher, Hakan Uçak, in his final paper. And right away, you're hit with this inverted mystery. The question isn't who did it, but why would a scientist kill their own creation so publicly?
So to understand why he pulled the plug, we've got to understand what the theory even was. What in the world was this S-matter framework? And what was it trying to do that made its failure so spectacular?
And you can see right here just how ambitious this whole thing was. Our standard model of the universe, our best guess, kind of relies on these patches. You've got the Big Bang singularity, where physics just breaks, some unknown particle for dark matter, and this mysterious dark energy. The S-matter framework, it was trying to fix all of that with one single beautiful idea. And that one big idea was a fifth dimension. Now hang on, this wasn't some other place you could just, hop in a spaceship and go visit. The theory described it more like a timeless reservoir of pure potential. The whole idea was that our entire universe, everything we see and experience, is just a projection from this deeper reality. Kind of like a film being projected onto a screen. Okay, so if our universe is just a projection, what's running the show? What are the rules? How do you get from a reservoir of potentiality to actual galaxies and stars and the laws of physics? Well, the framework came up with a sort of operating system for reality. They called it the Projection Codex. And this codex was built on a few pretty core rules. Non-contradiction, well, that's straightforward enough. No paradoxes. Minimal complexity basically says the universe is lazy. It always takes the simplest route. Finite resolution is a really cool one. It suggested that quantum uncertainty isn't actually random. It's just the pixel resolution of our reality. The ultimate goal was to derive all of physics from just a handful of rules like these.
It sounds incredibly elegant, doesn't it? A single, unified theory trying to answer cosmology's biggest questions from the ground up. So what on earth went so terribly wrong that its own creator had to just shut it down?
The theory killer, the intellectual brick wall that brought the whole thing crumbling down, was something the creator himself called the simulacrum paradox. And this gets right to the heart of the problem. Instead of those simple, elegant rules naturally creating the universe we actually see, the researchers found themselves having to add more and more complicated rules to the codex, rules that were specifically designed to fake the evidence. The theory wasn't explaining reality anymore. It was just becoming a machine for simulating it.
And you can really hear the intellectual honesty in Uçak's own words from that termination letter. He felt like the work was becoming a cheat. For him, a theory that has to invent rules just to mimic the evidence isn't a theory at all. It's just a puppet show.
And that right there, that was the critical line it crossed. See, a good theory in physics should have simple rules that lead to complex results that match what we see. This framework was doing the complete opposite. It was looking at our complex reality and inventing ridiculously complex rules just to match it. It was describing, not explaining.
But look, this wasn't just some philosophical disagreement about what a theory should be. The framework didn't just feel wrong. It was demonstrably, measurably wrong when you put it up against the cold, hard verdict of real-world data.
This slide just lays out the undeniable failures. For instance, the theory predicted a universe that started out cold. But when we look at the cosmic microwave background, it's a perfect heat signature from a blazing hot past. No way around it. The theory also predicted a weird hydraulic universe where space didn't really expand uniformly, but our measurements showed that it does, and with incredible precision. And it just couldn't explain time dilation, a proven fact of our reality. On every major test, the theory fell flat on its face. And this led to what Uçak called theoretical degeneration. The framework completely stopped making new, testable predictions. Instead, it just took observations we already had and gave them fancy new names. Oh, dark energy? That's just the hydraulic effect. Dark matter? Oh, that's S-matter. That's not science, That's just a relabeling exercise.
And that brings us right back to that powerful, incredible act of scientific integrity. For the lead researcher, to keep going would mean to just keep putting patch after patch on a theory he knew was fundamentally broken. So he chose to stop, to document the failure, and to get out of the way so new ideas could emerge. And all of this leaves us with a really crucial question, one that gets to the very heart of what science is. When a beautiful, elegant, all-encompassing idea smacks right into a cold, hard, undeniable fact, which one wins? I think the story of the S-matter framework gives us a very clear, and honestly a very admirable answer.